Okay, I want to look at chapter 7.3 and a couple of things on dealing with fractions. I told you earlier that I don't like fractions, so I try to eliminate them. Now this example that I've got right here, we have a particular way of solving this one that I've already discussed. And the way we do it is we use the reciprocal of 2 7s, multiplying both sides of that equation by 7 over 2. The 7s cancel, the 2's cancel, and all you're left with is the x. And let's see, the 8 and the 2 will cancel, give me 4 times 7, which is 28. So x is 28. Now what I want to look at is an alternative method that we could use in this one. You will need to use it on some of the other things that we're going to be running into, but let's just take that same problem. And what I want to do is I want to take that same equation, and this time 2 7s x equals 8, and I want to multiply it by just the denominator, by 7. If I multiply both sides of that equation by 7, these 7's cancel, and I get 2x, and over here 7 times 8 is 56. Now you know how to solve this one. You're going to divide both sides of that equation by 2. Well, 56 divided by 2 happens to be 28. So here's the issue right here, is I eliminated the denominator of this in this equation, and I end up with an equation that has no fractions. That's the concept that we want to use. Okay, now let's take a look at something here before we go on. And that's this problem right here. I know that 12 divided by 3 is 4, and it follows that 3 times 4 is 12. So if I take 12 divided by 0 and I get some number here, my question is, if I use this same logic right here, what number can I multiply by 0 and get 12? Well, obviously I can't. So what we say is that division by 0 is undefined. You can't do it. Okay? So anytime you have division by 0, you got a problem. Alright, so let's take a look at this one right here. If I have 8 divided by p, what value of p has to be eliminated? Well, p can't be 0. If p is 0, then I've got 8 divided by 0, and that can't happen. Alright, now how do we solve this one right here? Well, what I want to do is I want to multiply both sides of this equation by p. And I can do that because I know that p is not going to be equal to 0. Now what happens to the p's? Well, they're going to drop out. This p and this p will cancel, and the only thing that I have left is the negative 8. And over here, what have I got? Negative 72p. Well, now we're going back up to the same concept that I had up here. I've got a single line like this one right here, which I can solve. How do we solve it? Well, remember that I said that we're going to do the opposite of whatever it says. It says multiply right here, so what I'm going to do is divide this by 72. Now I'm going to go ahead and show the 72, the minus 72, on both sides of this equation. I'm going to do this for a purpose because I want you to recognize that what you will end up with, these two will cancel, and I'll end up with p, just like I said that we would. We're going to get rid of that 72. But now this thing right here, I have a negative divided by negative, so it's a positive. We're done with it. We don't have to worry about anything else. What is 8 divided by 72? Well, it happens to be, if I look at the fraction, it's simply 8 72nds, and that reduces to 1/9. Now this is a perfectly legitimate way of expressing this. 8 over 72 or 1/9 is actually what I want. You may end up with something like, just as an example, if I have, let's say, 29 over 4. Now that's not going to come out even. That's going to be 7 1/4. But this answer right here is a perfectly legitimate answer. Mathematicians accept that as a perfectly legitimate answer. It's not going to cause us any problems whatsoever. Okay, let's take a look at how we're going to solve this. Well, I want you to understand that this line right here, this line, we call it a fraction bar or whatever, actually has a name. It's called a vinculum. That's VINCULUM. Alright, now the vinculum basically collects the things on the top and the things on the bottom. So this entire piece down here is a single entity. It's just like parentheses. And what I can do now is take this equation and I can multiply both sides of that equation by x minus 4. Remember, that's over 1. And I'm going to multiply this side by x minus 4. Now, a word of caution, watch out for the negative sign here. Okay, so what happens? Well, this x minus 4 and this x minus 4 drops out. And the only thing that I have left is the 7. Now, what do I have on the right side? Well, I've got minus 8 and x minus 4. Okay, I want to look at this in two different ways. So let me recopy it over here. 7 equals negative 8 times x minus 4. Alright, the first way is I want you to consider that this is a term right here. It's a multiplication problem. It's a term. It's no different than 8x or 3z or whatever. I can divide both sides of this equation by negative 8. These are going to drop out, and the only thing that I have left over here is the x minus 4. And on the left side, I have negative 7/8. Okay, so what do we do now? Well, just like any other problem, you're going to try to get that variable by itself. You're going to add 4 to both sides of that equation. If I add 4 to both sides of this equation right here, I will have 4 minus 7/8. And if I add 4 to that negative 4, it's going to drop out. That's the reason that I add it. So I'll have x over here. What are we going to do with this one right here? Well, a couple of things. We can go back to elementary school and we can look at, let me slide it over here. 4 minus 7/8. I'm going to borrow 1 from the 4, make it a 3, and this is going to be 8/8. And this would be 3 1/8. Or I can change that to 25/8. Okay, that's one way. That's the way we did it back in elementary school. Well, I want to show you a different way. If I consider this whole number in terms of an 8, it's 32 over 8 minus 7/8 is my x, and 32 minus 7 is, in fact, is 25. So 25/8 is my value for x. Now, generally speaking, we don't use this one. Okay? Because anytime we're going to work with it, we have to convert it to this one right here. This is a perfectly good answer. 25 over 8 is a perfectly fine answer. Okay? Alright, so let's look at this other one over here. If you'll let me draw a vertical line first to separate these two little rascals. Cut down on the confusion a little bit. Alright, now what I can do is something you call the distributive property. And the distributive property says that 7 will be equal to negative 8 times x and negative 8 times negative 4. Well, negative 8 times x would be negative 8x. And negative 8 times negative 4 is positive 32. Well, we're right back to the way we started before. Now you know what to do with this one. We have to add, subtract 32 from both sides of the equation. And I'm going to go ahead and write it down in this step. Minus 32 and minus 32. Well, these are going to cancel. That's the reason I subtracted 32, to get rid of those two, and I will have negative 8x. And over here I've got 7 minus 32, and we recognize that that's minus 25. And if I divide both sides of that equation by 8, by negative 8, and I'm going to go ahead and write that down also. I normally wouldn't, but I will this time, because I want to emphasize the fact that these are going to cancel. That's the reason you divide by negative 8. But here, I've got a negative divided by negative, which is a positive. You're done with it. Don't worry about the signs anymore. And our answer will be 25 over 8. Exactly the same thing I had here. Either way is acceptable. Which way do you understand the best? It's entirely up to you. It doesn't make any difference to me. Sometimes this will work out a little better if this is a, for example, if this were, I'll say 72. Well, then I wouldn't have a fraction. I have 9 here. So it might work out a little better this way. Either way is going to work fine. You got to manipulate the fractions on this one. You don't have to manipulate the fractions on this one if you distribute. Okay? Let me see if there's anything else real quick that I want to show you. And yeah, I believe I do. I think I have one more that I want to show you. And that's this one right here. Okay. Well, now what I've got is I've got 3 terms. And they're not the same denominator. So what do? Well, I think about the least common denominator of 2 and 3, and that's 6. If I were going to add 1/3 plus 1/2, think about it, I would change that to a same denominator. Well, I think that we remember that that's going to be 6. This is going to be 3/6, and this is going to be 2/6, and I can add them. The number that I'm interested in is that 6, because what I want to do now is simply multiply all 3 of these terms by 6. And let's see what happens. Remember now it's 6 over 1, right? The 3 and the 6 will cancel. 2 times 1 would be 2, so I've got 2x. The 2 and the 6 cancel, and I've got 3 times 1, which is 3x. The 6 and the 3 cancel. Oops. And I've got 2 times 20, which is 40. Well, once again, I've got a nice easy problem that I can combine those two terms. 2 plus 3 would be 5x equals 40. Now, once again, you know that you're going to divide by 5, and the reason you divide by 5 is to cancel it. Can you divide 40 by 5 in your head? Well, most of us can. And now we've got an answer. X equals 8. Just for curiosity, I hadn't planned to, but let's take a look at checking it. If I have 1/3 of 8 plus 1/2 of 8, is that 20 over 3? Wow. Let's see, what's 8/3 plus 4? Well, 8/3 is what, 2 2/3 plus 4, and that would be 6 2/3. If I change that to an improper fraction, what is it? 18 plus 2 would be 19, or excuse me, 18/20 over 3. Well, look at there. Don't you love it when a plan comes together? So if I take this value of 8 and plug it back in here and here, I get a true statement, and that's the objective of the game. Okay, that's the practice that you have to work on as far as these fractions. Maybe just another little tip. If you've got some odd denominators, let's suppose that I have, I don't know, let's say 1/6 x plus 1/8 x equals 12. And I'm just making this up. I don't have any idea what the value is going to be. I'm just trying to get you to see what's my least common denominator. Well, what you can do is you can look at multiples of 8. Count by 8s. 8 times 1 is 8. Will 6 go into 8? Nope. 8 times 2 would be 16. Will 6 go into 16? Nope. 8 times 3 is 24. Will 6 go into 24? Yeah. Okay, so my least common denominator would be 24, and that's what I would multiply each one of these by in order to clear that fraction out. The trick is to take the larger denominator and look at multiples of that larger denominator. That's just kind of a tip for you if you can't see it. Sometimes it's easy to see. If I have 1/6 x plus 1/12 x equals 12, I know that my LCD is going to be 12. Because 6 goes into 12 and 12 goes into 12. That one's straightforward. It's only when those kind of odd things. Okay? One other little trick for you. If I have consecutive numbers, if I have 1/7 plus x plus 1/8 x equals 9, since these are consecutive, I know that 7 times 8 is my least common denominator. Okay? They are called relatively prime. Let's see. If I have numbers that have no factors in common, let's see if I can figure out one of those. Let's say 3/5 x plus 2/7 x. equals 5. I know that there's nothing that goes into 5 that will go into 7. So I know that 5 times 7 is my least common denominator. Okay, now those happen to be prime. They don't have to be prime. If I have, let's say 5/16 x and let's say 3/7 x equals 21. I know that there's nothing that goes into 16 that goes into 7, so I know that 16 times 7 is my LCD. And that's what you're looking for. If you want to clear that fraction, whatever 16 times 7, that would be what, 42, 112. I would multiply everything by 112 to clear that fraction out. Okay? Hopefully that makes some sense to you. All these numbers are relatively prime. It doesn't mean the numbers themselves are prime. 16 obviously is not prime. Neither is 8. 6 and 12, well, those aren't relatively prime anyhow. So. But you get the idea of it. Hopefully that'll help you, give you a couple of tips on working with this stuff. And we'll press on with something else next time.